Naming alkynes is very similar to naming alkenes, except for we're going to be changing the ending to "-ine" to denote that it's an alkyne parent. Also, since alkynes are linear, there is no E or Z designation to worry about. So what we're going to be doing is finding the longest chain containing the triple bond, numbering it to give the triple bond the lowest possible number, and then listing all substituents out in front along with their numbers. So starting with this first one, it looks like our longest chain will be the one right there. We want to number it to give the triple bond the lowest possible numbers, and so what we're going to do is start from the left right here. So there's 1, 2, 3, 4, 5, 6. From here on out it becomes pretty straightforward. You can see I have a methyl at number 4, so we will have 4-methyl. Now there are 6 carbons in the parent, so it's going to be hex, and then the alkyne occurs at number 2, so hex 2-ine. So 4-methyl hex 2-ine. For this next molecule, identifying the parent containing the triple bond would be that one right there. In terms of numbering it, we want to number it so that the triple bond gets the lowest of the possible numbers. And if we start from the right-hand side, we have 1, 2, 3, 4. The triple bond would get number 4. Going from the left-hand side, 1, 2, 3, 4. It would also be number 4. So the numbering in terms of the alkyne doesn't matter. Next, we'll take a look at the numbers of the substituents. You can see from either side we'll be going to number 2. There's 1, there's 2. So we keep going in. There's 1 at 3, there's 1 at 3. So numbering for the substituents didn't matter. So now we are kind of at our last priority, which is alphabetical. Number 2 is a chloro, number 2 is a methyl, chloro wins, and so we will be numbering this from the chloro side. So we'll have 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so it looks like we have an ethyl substituent, a chloro substituent, and a couple of methyl substituents. Chloro will come first, so this will be a 2-chloro, and then we'll go to ethyl, 3-ethyl, and 6,7-dimethyl, eight carbons is oct, and it's going to be 4-ine. So 2-chloro, 3-ethyl, 6,7-dimethyl, oct, 4-ine. Now that we know how to name both alkenes and alkynes, there is the possibility that you'll run into a molecule with both functional groups in the same molecule. That would be called an enine, and you can see in that name the alkene name and the alkyne name, an enine. What you're going to do in that case is find the longest chain in the molecule that contains the greatest number of double and triple bonds. We want to try to get as many in there as we can. The parent is called an enine. And what we'll do to show how many double and triple bonds we have is use di, tri, tetra, etc. on there. So, just as a way of practicing general enines, let's say you had 6 carbons with 1 alkene and 1 alkyne. That molecule would be called a hex for the 6 carbons, and then ene, there's only 1 alkene, ine. Now what you're going to see that we're going to do when we go through and actually name a real molecule is we will be putting a number in front of ene and a number in front of yne to show where they are. How about 6 carbons with 2 alkenes and 1 alkyne? Again, it's going to be hex. Now the next thing, since there are 2 alkenes, it's a diene. And since di is not a vowel, we're going to have to go hexa, diene, yne. Notice I dropped the E off the ending of ene right there, because in OChem, Y is a vowel, and I don't need it. Now, 6 carbons, 1 alkene, 2 alkynes. That is going to be hex. I don't need hexa because I have just 1 alkene, so it's hexene, and then diene. Notice since there is D, which is not a vowel, I had to put the E. We'll get used to it, don't worry. Okay, so here we go with some practice, just in terms of identifying the longest chain and numbering it and whatnot, the different situations you could run into. So our first molecule, let's go ahead and identify the parent chain in the molecule, which would be that one right there. And in terms of numbering it, you're going to start out numbering the carbon atoms in your parent chain at the end closest to the first multiple bond. Could be an alkene or an alkyne. You want to give your multiple bonds the lowest possible numbers. So what we'll do in this case, since we're going to start at the end closest to the first multiple bond, is we will be starting at the triple bond right here because it gets number 1. So this would be numbered 1, 2, 3, 4, 5. Now let's say when you do this that there's a tie at the first multiple bond, like this second molecule that we have right here. If I start at this end, I'm starting at number 1. If I start over here at this end, I'm starting at number 1. So I have to break this tie. And so what you do is very consistent with what we've done before, is you go in further. You start numbering at the end of the molecule closer to the second multiple bond. If that doesn't break the tie, keep going into the third. You just keep going in, trying to keep everything lowest possible numbers. So you can see that right here we have a double bond closer to the triple bond end. And so that is where we're going to be starting our numbering, at the triple bond. So this will be 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, now let's say, moving on, that it's the same from either direction, as in this example here. No matter what I do, it's going to be number 1 on both sides. There are no double or triple bonds in between the two to help break the tie, so something else has to break it. In that case, if there's a complete tie with the functional groups in terms of their numbering, then the alkene has the higher priority. And as the higher priority, it is going to get the lower number. So, in this particular example, I would be starting here. 1, 2, 3, 4, 5, 6, 7, 8, 9. The alkene won because there was a tie with the numbering. Okay, let's go ahead and start some examples. You can see outlined in red on this molecule is the longest chain containing the most number of double and triple bonds that we could get. We're going to have to number it, and we want to start at the end closest to the first multiple bond. So in that particular case, we will be starting with the alkyne because we could start at number 1. If we'd started at the double bond side, so we had started right here, we wouldn't have a number until 1, 2. It wouldn't be till number 2. So we want the number 1. And so we'll go 1, 2, 3, 4, 5, and 6. Now what I'm going to do is consider that double bond and see if I need to worry about E or Z. Because now, since I have alkenes, there is the potential that you're going to have to label it E or Z to designate its stereochemistry. There are two methyl groups off of the end of it. They're interchangeable, and so I could draw it either way and it wouldn't matter. And so there is no E or Z to worry about in this case, which is very, very nice. So, the next thing we have to do is we have to deal with naming this complex substituent group right here. Taking a look at it, let's start the point of attachment at number 1, and then 2, and then 3. So at number 3 I have 2 chloros, and the parent sort of that's attached is a propyl group. So this will be a 3,3-dichloropropyl substituent, and it occurs at number 4 on the parent. So let's go ahead and let's name this thing. At number 4 on that parent chain, I have that big substituent, which would be 3,3-dichloropropyl. And then at number 5, I have a methyl. There are 6 carbons total. Now I'm into the parent, so 6 carbons total. So it's going to be hex. And remember, it's an ene-ine, so the ene part goes first. So we'll have 4 ene. And the ine is at number 1, and I'm going to have to squeeze it in down here. 1 ine. Now notice that one thing I did is I dropped the other E. There is no E at the end of the ene. And the reason for that is because of that Y right there, because Y is a vowel in OChem, and so I was able to drop that E at the ending of ene. If there had been an E or a Z, had that occurred, it would have made sense to stick it right with the 4 right there. But I didn't have to worry about it, so 4 just stands alone. To our next example, you can see highlighted in red again the longest chain that contains, in this case, we were able to get all of the multiple bonds. Now we're going to have to number this thing, and we want to keep the numbers of the multiple bonds as small as possible, so let's see which end is closest for starters. If I start at the alkyne end, it's 1, 2. Let's start at the alkene end and see. 1, 2. Okay, that didn't help us, so we keep digging in. Starting again at the alkyne end. 1, 2, 3, 4. There's something at number 4. Go to the alkene end. 1, 2, 3, 4. There's nothing. I don't hit that other bond until 5. So I am going to want to be headed in from the alkyne end because my second multiple bond has a smaller number. So let's go ahead and let's number this thing up. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, looking at the double bonds, do I need to worry about E or Z on the double bond between 7 and 8? The answer is no, because it has 2 methyls at one end, and they are interchangeable, so there's no E or Z to worry about there. In terms of the other double bond, the one right there, I do need to worry about it there, and that one has the designation of Z. So, next thing to do, I have a methyl substituent, and the other substituent is a sec-butyl. So let's go ahead and let's name this thing. Sec-butyl will come before methyl, so we're looking at 5 sec-butyl. 8-methyl. Now it is 9 carbons, so it's going to be based on nonane. There are 2 alkenes, so it's going to be a diene and then an ine. So we have none. The next thing to come is that diene. So that since D is not a vowel, I need nona. Now, the double bonds. There is one at 4, and it is a Z. And then there is one at 7, and it doesn't have E or Z, so I don't need to worry. And so that's diene. And now the next question becomes, does that E belong or does it not? Let's just park it there for a minute. And the next part is going to be the triple bond, which is 2-ine. So, if you take a look at this, remember Y is a vowel, and so I actually do not need this E that is at the end of the diene. And I'm going to just carefully erase it. There it is. And let's go ahead and try to recreate that in just a little better. Make that longer. Okay, so it's 5-sec-butyl, 8-methyl, nona, 4Z, 7-diene, 2-ine. Okay, now I think we've gotten to our last example. This has 2 triple bonds and 1 double bond. You can see the parent chain highlighted in red. In terms of the numbering, either end that I start, I go in, there's something at number 2. So I keep going in. Starting from the alkyne end. 1, 2, 3, 4, 5. I hit another thing at 5. 1, 2, 3, 4, 5. I hit another multiple bond at 5. The numbering here is a complete tie in terms of the functional groups. So when that occurs, what you do is the double bond has the priority. The alkene has the priority. What that means is we will be numbering from the alkene side. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 carbons in this parent. And the alkene, there is no E or Z necessary, since on the one side it's both methyls. I could interchange them and it would not matter. So this molecule is wonderful. Alright, and I just have, it looks like methyl substituents. So let's go ahead and let's name it. We'll start with the methyls. There's one at 2 and 2 at 7. So we will have 2, 7, 7 trimethyl. Remember, each one gets its number even if they are on the same carbon. So 2, 7, 7 trimethyl. Now it is dec. Now am I going to need deca or just dec? The next thing to come in the name is the alkene. And there's only one of them, so it's going to be ene, which starts with a vowel. So we're going to have dec 2 ene. And I'm going to put the E there, and we can always go back and erase it if necessary. So dec 2-ene, I didn't need deca because of the E. And then for the alkyne, we have 5, 8, and it's a diene. And it turns out that I do need this E because D is not a vowel. So it's 2,7,7 trimethyl dec 2-ene 5,8 diene.